we have fx equals x cubed plus 3x squared plus 3x plus 2. So what's the procedure to find the inverse? Well, first we make y equals, yeah? Right. Now we need to find x. Right, so. Okay. I did something sneaky here. Does anybody spot anything about this cubic? Anything interesting? I give you a clue. Look at the numbers in front of them. What are they? 1, 3, 3, 2. That's almost like 1, 3, 3, 1. So if I just replace this 2 like this, then you realize that this is Pascal's 1331, which means it can be represented like this.
What if someone did not see that?
Well, I just feel sorry for them, firstly. And then secondly, they wouldn't do something as sneaky as that in the exam.
That's the thing with math. You don't know when to change numbers or when you're allowed to change.
Intuition, maths intuition. Yes?
Yes.
Yes, maths intuition. All right. Now that I have it like this, it probably is clearer what to do. So now you have y minus 1 equals x plus 1 cubed. So cube root y minus 1 equals x plus 1. So then minus 1 plus that is equal to x. And there you go. You got your inverse function. Inverse of x is equal to minus 1 plus cube root x minus 1. And interestingly enough, if you were to look at this line here, is this function 1 to 1 or many to 1? It's 1 to 1. So this is a cubic that is 1 to 1, not many to 1. Yes? Look at that, write it down, process it, accept it, we'll move on. And hate it, yes.
What did you do in the step before the last one?
Oh, I just took the cube root of both sides and then brought the 1 to the other side. I cube root both sides here. I put a cube root on both of them. On both sides. You got that? Yep? Yes? Okay. Anything else from that? Number 2, which part? Huh? Anyone? Okay, well, pick one for me. Can you hand me the page? So which one am I doing? E. But all right. Here you go. So we want a domain. So cosine. What shape does cosine make? Well, we know it goes, yep, top, down, and then it goes back up. We only want this piece, the top to the bottom, because it's in this piece that it's 1 to 1. So what's the angle here at the start? 0. And the angle here at the end is pi. So we need the angle here to be between 0 and pi for the cosine to be 1 to 1. If it is not between 0 and pi, it means its value is repeated. So you want between 0 and pi for cosine. Can you picture sine? What would you want for sine? Come on. Wakey time. What would you want for sine?
Half pi to half pi. Minus half pi to pi. Half pi.
Minus a half pi
To half pi.
to half pi. That would do it. Yeah. You remember these graphs from semester 1? I shall assume everything in semester 1 was learnt. Okay. And also, you solved this in semester 1 as well. You take pi away from all sides. Take 3 pi away from all sides. So that's gone. And then here you have minus 2 pi. And then you divide by 5. So there you go. Domain is minus 3/5 pi to minus 2/5 pi. And that is the answer for domain. Is that what I was asking for? Yeah, why not? Got that? We are happy? We are happy. All right. So next topic now. So we have 2 lessons left in this chapter, and then believe it or not, we already have 2 questions from section B covered. So the first topic was calculus, and that usually is question 1, and then the second topic is all about functions, and that's question 2 in section B. So actually we already have 2 section B questions nearly covered. Okay, so far so good. So next topic now, and I can help demonstrate this by using derive. So what we're going to look at now is something called transformations of functions. So this is altering, this is changing your function. Okay, so let's see. We've got fx equals, let's say, x squared plus x plus 1 defined. Alright. So if I want to draw this, let's get derive to do it for me. Y equals fx and plot. There you go. But what do you think happens if I do fx minus 1, if I plot that? Yeah. If you plot this function, it'll be the same, but it looks like it was moved to the right. So this is where derive comes in handy for demonstrating here. See how it looks like it's moved to the right? And then if I do plus 1 here, should look like it's moved to the left here. Now, what about if I do plus 1 on the outside? It looks like it should move up. See? And then if I do minus 1, it's moved down. So we can see plus 1, minus 1, how we can move it left and right and up and down. Now let's look at what happens if we multiply it. So what about y equals f 2x? Whoop. Compress. So it'll look skinnier. Okay, so if I look at this, see that? Compress. And then what about if I did a half x? Expand, yeah. See? Yeah. Now, what about if I put a 2 on the outside?
Move up,
Not quite.
move down. Overside.
No. Nothing. Oh, I'll do something. Yeah, but how? It looks like it gets stretched vertically. Okay, so if you look at this now, well, actually, you know what? I'll just delete that middle one. Okay, and I'll draw this one again, and then I'll do this one. And if I zoom out, maybe you can see how the blue one now looks skinnier than the red one, like it got pulled up. Yeah? Okay, and then the last one, of course, if I did a half, like this, what do you think? Yeah, maybe the opposite, huh? It looks like it gets squished down. Oh yeah, and then just 2 more to show you. So again, we have this one, and now if I do this, yeah, but which way around does it flip it? The x-axis gets flipped around. No, you see, well, it's like this. You take it like this, and then you turn it around. This is called reflection. Reflection in the y-axis, because it's like the y is the mirror. The y-axis is like the mirror. So we say reflection in the y-axis, like reflection in the mirror. Yeah? And then what about if I put the minus on the outside? Upside down, which is reflection through the x-axis. So if you were to look at question 1 here, all I'm asking, or I'll give it to you in a moment, all I'm asking you to do in question 1 is to describe each of the transformations. So like, for example, my first question is y equals 3fx. So what type of transformation is that? Vertically stretched by a factor of 3. So number 1 is okay, because you've kind of seen that in semester 1. But semester 2, let's look what happens when you put multiples together. So that's more like the new one. So suppose I have something like this. Y equals AFB. And by the way, this is the normal way of writing it. You write B times x minus c, close bracket, plus d. It's a tiny bit different to the sine and cosine that we did in the first semester. So if you remember, in the first semester was bx plus c, I think, whereas here we're doing bx, x minus c in brackets though. Yeah? Okay, did you write that down? Yes? Okay, so like for example, let me see. Yeah, no, maybe we won't do one just quite like that just yet. Okay, so let me pick something smaller. So if I say y equals 2 f3 minus 1 plus 4. And we want to figure out how the graph changes if we plot this instead of the original y equals fx. So the real question here is, what order do we do things? Like, for example, do we first move it and then compress it? Or do we first expand it and then add 4 to it? What's the order here? Well, the order would be, or no. Well, I mean, does anybody know what the order is here? Now, if we don't know, we can have a look at the graph and try and figure it out, okay? So really, the way I see it is, there's kind of two main choices. You know, you either do this first and then this, or you could do this one first and then this. So maybe you move it to the right 1 unit and then compress it 3 times, or maybe you compress it 3 times and move it to the right 1 unit, or maybe it doesn't matter. So what we'll do is we'll go with this order and see if that makes the right graph. So we'll say this first. I'll write I instead of A. So we'll go with this, and then I think this, and then we'll try this. So what do we think should be the order here? First we move it to the right 1 unit, yes? And then we compress, how much? By 3. And then next we multiply the height by 2. You don't need to write this line down just yet because we're not sure if it'll work. We have to look and derive. And then the last thing we do is we increase the height by 4. So let's see what happens. I just need you to write this down so you can read it back to me. Did somebody write that down? Yeah, okay. So if I delete this, okay. So I have y equals, what have I got? 2f
3 x minus 1 plus 4.
Okay. So I'll draw this. Oops. Okay, and then I'll draw the other one. Now you can't see the first one, so I'll have to zoom out. Okay, do you see it there? So let's go back. What do I said to do first? First we move it to the right. Okay? So let's try and do it bit by bit. So the first one I said was move it to the right. So that goes along there. And what was the next thing I suggested? I think it was compressing by 3. That's that green one there. So you see how it's getting closer to the red one? What did I suggest next? Double the height. Okay. There it is in black. And then finally, plus 4. So if this works, that red one should then change color because there's a new graph sitting on top of it. Yeah, well, you can't even see where the new one appears because it's already on top of the red one there. Okay, so what I'm trying to get you to here visualize is the graph changing as it goes from the original into this new form. Okay? I missed my opportunity to say this isn't even my final form. I'll have to remember that next time. Okay, so I'll do another example like this. So you can write this one down. Now, I just wrote these symbols down to write it quicker, but in the exam you would need to use the proper vocabulary. Does anybody remember the verb for moving? You don't say move left or right, really. What do you say? Not transfer, close. Shift is okay, and there's another one. Translate. Transfer is okay as well. I got your message from Lorraine, by the way, but I didn't actually expect to see you. Oh, okay, it got cancelled then, okay. Okay. Can I do another example now? Yeah? No.
What's the name of the last one?
Transformations. Yes? Okay. Right, so let's take this example. We all know x squared. So I want to draw this one.
These two are different, right?
Oh yes. Now, first thing you need to do, this is given, yeah, is you need to write this in the usual form, which is 2f3 x plus 2 plus 1. Do you see what I did there? I took the 3 out from these and put it in the front here. Okay, so if we were to write down the change in the graph here, what would happen first? It goes to the left 2 units, and then what's next? Compress 3 units in the x, and then next expand 2 units in the y, and then finally you increase it, so you go up 1 unit.
That's it?
No, now we need to draw it. So,
And is it satisfied?
I'll just put the quadratic here. So red is the original. So that's red, original. Okay, and then we'll go blue, green, this kind of pinky purple, whatever that's called, and then we'll finish with orange. Okay, so the blue one first. I move it left 2 units, so that would look like this. Yeah? Then in green now, I compress it 3 units. So what happens here? It gets squished, doesn't it? So that goes like that. And then I expand it vertically 2 units, so then that gets stretched up. Oh, this is looking terrible. And then I move it up 1 unit, so I don't know. It's there. Of course, don't draw that. That's stupid. We'll draw it nicely here.
No.
I'll go back.
Are we supposed to draw?
Only the final part, not all the little steps. Wait, hang on. They could ask you to draw it, but they actually haven't asked you to draw it yet. So, no, chances are they won't. Okay. So now I have fx is equal to x squared. And what is my new function? 2f,
3
yeah,
plus
6. Well, we'll write it like this. It doesn't matter. Plus 1. All right. So I kind of want this quadratic on the left up a little bit, maybe a bit squished. So what I'll do first is I'll draw the original. Okay. Now, time for this one. Yeah. It's a little bit further to the left than I did in my graph. Maybe because I didn't have any units on my graph. But we were expecting it squished and to the left quadrant, upper left quadrant.
So it will always go up, right? Or the...
No, because it went up because there was a plus 1 at the end.
So how do you know if we have to move left or right?
That's if it's a plus or a minus. Yes. Now, You can draw this if you like. Now, let's try and connect some lessons together, you know, connect the maths. So if you were to look at line number 4 there, what does this remind you of? A lesson you've done recently? Maybe a lesson that you did on Monday? Where you put, what type of function is 3x plus?
So f would replace the x squared by 3x plus.
That's it. What's the name of this? You're right. Composition.
Composition.
Yes, yes. So you put the 3x plus 6 inside of the f, right? And then you multiply by 2 and add 3. So you could make a new function here, 3x plus 6 composed with f, and I'll get derived to simplify this. You got this quadratic. And if I draw this quadratic, do you think I will make one of these two or a different one? What do we think? You're saying different?
The blue one.
Yeah, the blue, the red, or something else.
The blue.
Let's see. And the answer is yes, the blue one. But of course it is, because this is the same as this. I've just simplified it. The whole point of this lesson, though, is how to draw this transformation without having to simplify it, okay? So like if I did something like this instead, it should still do the same thing. It should still, oh sorry, I should say x, not 2. What did we say? It should maybe get squished up to the upper left corner. Yeah, so if I draw this now, let's see. So that's the original. And then this one here, let's have a look at it now. See, the same thing happened. But I think we all agree, if I was to try and expand this and graph my result, so if I look here, that we all agree is more difficult to graph, you know. So the nice thing about these transformations is that you get a simple function that you can graph, and then you look at some complicated form of it, and by following the steps of how it changes, you don't even have to work out what this is to draw the graph. So that's the key here for transformations. Okay. So that's number 2. So now the last one, type question 3 here. So, do you need to write this down? Yeah, that's, yeah. It's like that flag in that parade, you know? You know what I'm talking about. That American parade. Okay.
So that's the main comfort.
What? I got a bit lazy. I shouldn't be using left and up. I should be using the proper verb, which is translate left, translate right. Okay. Go to new page? Yeah? Okay. Y equals f 3 over 2x minus 3 minus 2. And A is the point minus 1/8. Okay, so I give you this function. I don't even tell you what it is though. I don't tell you what f of x is. So this could be some weird function. And maybe here is the point A here. Okay, and then what will happen is it'll be transformed to some new location, wherever. And the A gets moved to maybe over here. And my question is, if the A starts here, where does it end up after you transform the graph? So actually you just use the same rules as before. But before you do that, you need to write this in the usual form. So what can I do? I can take out the, I want to take out this here, so 3 over 2. X minus a half minus 2. Because if I multiply this out, no, that's the wrong way. Not a half, 2. If I multiply this out, I get back the original here. Okay, so what do I do first? What tree, where? This tree here? Oh, it's still there because I factored out 3 over 2. So if I multiply 3 over 2 by 2, the 2's cancel, leaving me with the 3. So, I mean, it does go back to the original. Okay, so what do I do first? So we start off at minus 1, 8, and then this gets moved to 2 to the right, yes? So where will it end up? 1, 8. And then what does this do? It compresses, doesn't it? Compresses by how much? 3 over 2, 1.5, yeah. So you need to divide now by 1.5, which is a little bit messy. So 1 divided by 1.5, what's that, 2 over 3? Yeah. I first applied this rule, which says this moves the graph to the right 2 units. So minus 1 plus 2 is 1, yeah. And then finally, what do I do with the minus 2 at the end here?
6.
Yeah, well, describe what it does.
Move it down.
Move it down 2 units. No, you know from semester 1, I need a question, not a statement. So what don't you understand?
The last one.
Okay. And your question? Okay, so it's the same last line. I'll go through the last line again. Okay. So look carefully, please. What rule do I use first is this one. What does this do? Moves it to the right 2 units. Describe moving to the right in terms of how it changes the x value. If you move to the right 2 units, what happens to your x? Does it get bigger or smaller? Bigger by 2 units. So minus 1 plus 2? 1. Now the next one is this here. What does this do? No? Compresses. So then you have to divide by 3 over 2. So 1 divided by 3 over 2, if you could type that on your calculator, you'd get 2 over 3. And then finally, what does the minus 2 here at the end do? It lowers the y by 2 units. So, yeah, drops it. So the 8 becomes 6.
And what happens to, oh, it's because here we don't have 8, right?
What do you mean? Oh, there's no number in the front here. Yeah, so there's no expansion vertically. But let's suppose there was a number, like 6 here, then that just means the y would get multiplied by 6 before you do this taking of 2. Will I do one that has an a in it, yeah? Okay. So can you write that down? Okay, next one now. So, next example. You don't have it? All right, I hope so. 2f minus 2x plus 4 minus 2, and the point is 4 minus 3. So firstly, we need to write it in the usual form, which is 2f minus 2 x minus 2 minus 2. Okay. Yes. So again?
Could we put the minus in?
No, I shouldn't say that, yeah. If you need to, okay, yeah, let me be maybe a bit more explicit. Where to go? You see this x here? This has to be an x, not a minus x, not a 6x, not a half x. It has to be an x. So if there was a minus on it, that must come out. You can't have any coefficient on the x here except for 1. Okay, here I am. All right. So what rule applies first? 2 to the right. So what does that make? 6 minus 3. Done. And then this 2 here, what does that do? It compresses 2 units, so that's 3. No, I haven't done the minus yet, actually. 3 minus 3. No, the minus. What does a minus do? It flips it around, doesn't it? So instead of having 3 here, what would I have? Minus 3. Because it just goes around like this. So all the positives become negatives and the negatives become positives. Okay, what's next? Yes, Faisal?
Why did you divide by minus?
What? Why did I do what?
6. How did you
Remember, Faisal, the 2 compresses it by 2 units?
Why not minus?
So 6 divided by 2 is 3, isn't it?
So we don't consider the minus.
No, I'm doing the minus in another step. I'm not doing too much in one step. I've just done the 2. Now I did the minus.
But we could like divide minus 2.
I guess, but yeah, alright, that's fine. I wouldn't. You can if you want. I don't like that. I won't do that. Alright, what's next? Yeah, it expands 2 units vertically. So what do we get? Minus... Oh, no, there we go. Minus 3 and... no, don't. Minus 3 and minus 6.
Why did you get the minus? From where did you get minus 2?
Oh. Please, you'll make me feel better if you say, I was listening, I didn't understand, because right now it sounds like you just weren't listening.
I was listening, but I didn't.
Good. What happens was, the minus here, that flips the graph around. So this going from here to here is me applying the minus to it. So remember, like minus x, that's a reflection. Okay. And then finally, the minus 2 at the end here, what does that do? Down 2 units. So I finish up at minus 3 and minus 8. So for example, let's pretend this f of x was a quadratic that looks like this. And let's pretend the a is its minimum. Then when you calculate the new graph here, where would the minimum be? It would be here. Okay? And usually that's what happens in the exam. Usually they give you a graph, and usually they tell you where the minimum is, and then they say, applying the following transformation, where will the minimum point be moved to? That is very typical for the exam. Okay?
I have some questions.
Yes?
Why did we keep changing before the number in front of the x? Like, why we don't keep 4? Why is it 9?
This 4 here. Oh, where's my pen? Here. Why do I change it into this? There's not really any good reason for it. The only reason is because, where's it gone? This here is what's called the normal convention, okay? I mean, you don't have to change it, but then if you do, it might change the rules I've taught you. And if you look in A-level books, they'll always write it in this form. So there's no reason that it has to be like that. It just happens to be done like that. So we always like to write it with brackets x minus c and take a common term out. There we go. So we started here, and then that was for just regular fx, and then after this transformation, our point got moved to here.
This is,
Well, if it was a minimum, this is the new minimum, yeah, and if it was a maximum, it's the new maximum or whatever.
That's the new one, right?
Yeah, like if it was representing a minimum point, that's where it would be now. Yeah? Yes.
Semester 3 doesn't make any sense.
Some would say semester 1 didn't make any sense. Do I want to show you something? I think I do. Okay, but don't write this down. Don't write it down. This is just for bonus. Okay, so we have y equals 2f minus 2x plus 4 plus, what did I say? Minus 2. And let's pretend a was the minimum. So where's the minimum here? What's the value of x? X was equal to 4. Okay, so that means, for example, f derivative of 4, what should that equal if it's the minimum?
Minus 3.
0. So let me calculate the minimum of this new function. So if I want to find the minimum, what would I need to do? Calculate the derivative. Yes? So if I calculate the derivative here, what rule do I need? Well, you have a function inside of a function, so what rule? Chain rule. So you have 2, and then remember the chain rule, you differentiate the outside, and then you multiply by the derivative of the inside, which here is minus 2. And you want this here to equal 0. So 2 times minus 2? Minus 4, yeah? But you don't care about that because you can cancel that because of the 0. So you want this to equal 0. Well, you already know from the previous part, what number here do you need to make this equal to 0? What do you need? Where?